take down this example. The primary and secondary winding, of 500 kVA. The primary and secondary winding of 500 kVA transformer. So the first thing we are given was what? 500 kVA. Now what is the 500 kVA again? We are given what? Our apparent what? We are giving apparent power to be what? 500 what? kVA. And I said the kVA is what? Kilovolts amperes. The primary and secondary winding of 500 kVA transformer have a resistance of 0.42 ohms and 0.0011 ohms respectively. So what are we giving there? We are giving our R1 to be what? 0.42 ohms and R2 to be 0.0011 ohms. Let's go on. The primary and secondary voltage are 6,600 volts and 400 volts. So what are we giving next? So we are giving V1, which is our primary voltage, to be what? 6600 volts. And we are giving what? V2 to be what? 400 volts. Respectively. And the iron loss is 2.9 kilowatts. And the iron loss is what? 2.9 kilowatts. Now what is our iron loss? We represent our iron loss as what? PC. And they said our iron loss is a constant and is given as what? 2.9 kilowatts. Calculate the efficiency on A, full load, B, half load. So we are given to calculate the efficiency on A, full load, and B is what? Half load. Calculate the efficiency on A, full load, B, half load, assuming the power factor of the load to be 0.8. Assuming the power factor of the load to be what? 0.8. So what is the power factor there? We are giving what? Packing factor, PF, to be 0.8. So if you are not hearing packing factor, you'll be hearing power factor. So what's the first thing? The first thing is to calculate for what? Full load. Now after calculating for full load, what's the next thing? You now calculate for your what? Your half load. Now, our parameters given, the first thing that was given was what? Our apparent power. And this apparent power was given in what? Kilo. So let's convert what we have here from this kilo to what? Normal volts amperes. So converting this to normal volts amperes, we have what? 500 times what? 10 raised to the power of 3 VA. So we succeeded in removing what? The kilo, and we've gotten our unit to be what? Volt ampere. The second thing that was given in the question was first resistor. That's the resistor of the primary what? Coil. The R2 is the what? Resistor of the what? The secondary coil. We are giving voltage of the primary coil, and we are giving what? Voltage of the what? Secondary coil. Now the next thing that was given here was what? PC. And our PC is what? Our PC is what? Iron loss. Our iron loss was given. Now, what should come to your mind is, we are looking at all our parameters, but something is missing. What is missing? Current is missing. Why is current missing? We know that what? Our copper loss is equal to what? I1 square R1 plus what? I2 square R2. where I1 square R1 is what? Your primary what? Loss, copper loss. While I2 square R2 is your what? Your secondary copper loss. So the first thing that should come to your mind is, how do we get what? The current here. But look at your equation, look at your parameters given. You were given what? Power. But we know that from elementary physics, power is equal to what? Current times what? Voltage. That's what we know. Now, if we are to find this current, then we are using this formula to get what? I1, and we are getting what? I2 as well. So we simply use this formula which says what? Power is equal to what? Current times voltage to get what? I1, which is the what? Current for the what? Primary copper loss, and the what? Current for the what? Secondary copper loss. So how do we go about it? We know our power here to be what? 500 times 10 raised to the power of 3. So to get our I1 from this equation will simply be what? P divided by what? V1. We already know our V1 to be what? 6,600 volts. So if we use this equation to get our I1 will simply give us what? 500 times 10 raised to the power of what? 3 divided by, what's our V1? Our V1 is 6,600. 6600. Now, if you do this simple calculation, what are we going to arrive at? We'll simply arrive at what? 75.8 amperes. So we've succeeded in getting what? The current for the what? The current for the primary what? Copper loss. Now let's get the current for the what? Secondary copper loss. To get the current from the secondary copper loss, we know that what? I2 is equal to what? P divided by what? V2. Now what is our V2? 400. And what's our P? Our P is what? 500 times 10 raised to the power of what? 3. So I2 will simply be what? 500 times 10 raised to the power of 3 divided by, what's our V2? 400 volts. So if you simply do this calculation, you arrive at 1250 amps. So we succeeded in getting I2 and what? I1. Our I1 is what? 75.8, and our I2 is what? 1250 amps. What's the next thing? What should come to your mind is, let's calculate for what? Our copper loss. Because from our copper loss equation, we can get what? The primary copper loss and the what? Secondary copper loss. So the first thing that we should do is to get our what? Primary copper loss. To get our primary copper loss, we know I2, we know I1 square, and we know what? R1. Now what is our I1? We know I1 to be what? 75.8. So if you do that, we know that from our equation, primary copper loss, it's simply what? I1 square, R1, and this is equal to, what is I1? I1 is what? 75.8 amps, all square, times, what's our R1? Our R1 is what? 0.42. Calculation. If you do your simple calculation, you simply arrive at what? 2413.2. So this is our what? Our primary copper loss. And what is your unit? It's in watts. Now, since we've gotten our primary copper loss, the next thing is to get your what? Secondary copper loss using what? This equation. Now, getting your secondary copper loss, we know that to get our secondary copper loss, we'll use what? I2 square R2. We've gotten our current, and we know our what? Our second resistor. Now, the second resistance here is what? 0.0011 ohms. And we know our I2 to be what? 1250 amps. So let's substitute these values into this equation. Now, if you do that, you simply arrive at what? 1250 square multiplied by R2 is what? 0.0011. Now, if you do this simple calculation, you simply arrive at 1718.8 watts. So we've succeeded in getting our secondary copper loss and our what? Our primary copper loss. But we already know that we are calculating for what? Copper loss. And we know that copper loss is equal to what? Primary copper loss plus what? Secondary copper loss. So what you simply do is take what you've calculated, which is what? 2413 and what? 1718. Add them together to get your what? Your total copper loss. You simply do that, you have your what? Your copper loss to be what? Your primary copper loss plus your what? Your secondary copper loss. Now you already know your what? Your primary. And you already know your what? Your secondary. So what is stopping us from adding both of them together? Now if you do that, you simply have your what? Your copper loss to be equal to what? 2413.2 plus what is our secondary copper loss? Our secondary is what? 1718.8. Now if you do this together, we'll have what? But add this and this, you simply have what? 4132 watts. So we have our copper loss to be what? 4132 watts. But remember, we are giving PC to be what? Our iron loss. And our iron loss was given as what? 2.9 kilowatts. So what we are going to do is, let's convert this to what? Kilowatts. So we have the same what? Values as your what? Your losses. Don't forget, what we are calculating for is what? Copper loss. This iron loss was already given to us as a what? As a constant to be what? 2.9 kilowatts. Now what I'm saying is, we are having this as watts and we are having this as kilowatts. Let's convert this loss to what? Kilowatts. Or better still, you can still convert what? Your iron loss from kilowatts to watts. But since we are giving this as a constant, as what? Kilowatts, let's convert our watts to what? Kilowatts. So to do that, you simply divide this by what? 1000. Now if you do this calculation, you simply have our what? Our total copper loss to be what? 4.132 kilowatts. So we've achieved both parameters to be what? To be in what? Kilowatts. What's the next thing you are supposed to do? The next thing is calculate for your total losses. Calculate for what? Your total losses. Now to calculate for your total losses will be equal to what? Copper loss plus what? Iron loss. We know our copper loss to be what? 4.132. And we know our what? Iron loss to be what? 2.9 kilowatts. Now let's add both of them. If we add both of them, we simply arrive at 4.132 plus 2.9 all in what? Kilowatts. So if you do this calculation, simply arrive at what? 7.032 kilowatts. So you've calculated for your what? Your total losses. What should come to your mind is, what is the next step? We are succeeded in getting our what? Our total loss, where we looked for copper loss and what? Iron loss. We added both of them and we arrived at what? Our total loss to be what? 7.032 kilowatts. Now the next thing that should come to your mind is, how do we calculate for the efficiency? Now we said that what? Efficiency is equal to what? Output power divided by what? Input power. This is our efficiency. Now, what should come to your mind is, we have not calculated for what? Our output power, and we don't also know about our input power. So how do we go about it? Our efficiency, we know that our efficiency is equal to what? Output power divided by what? Input power. Now, before you calculate for your output power, you first get your what? Input power. Now, recall that your input power is equal to what? Output power. Now, what is your output power? The power you've gotten. Your secondary what? That's, we are talking about, when we talk about the output power, then we are considering what? The secondary side of the transformer. Now, plus your what? Your losses. Now, what is the losses there? The losses is what? Both your what? Your copper loss and your what? Your iron loss. That is the losses we have here. Now, from this equation, we can simply get our output power. Now, from what we have there, we know that our output power will be equal to, take this to this other side of your equation. So addition crossing an equality sign, it will simply turn to what? Subtraction. So we simply have what? Input power minus what? Losses. Now, if you apply this equation you have got it to be what? Input power minus losses to what we have here as our efficiency. We will simply arrive at efficiency is equal to, what is our output power? You know our output power to be what? Input power minus losses. So we simply have what? Input power minus losses divided by input power. So we can still simplify what we have here to be what? Efficiency is equal to input power divided by what? Input power minus losses divided by what? Input power. So if we do that, we are seeing what? Input power divided by input power. So this and this can cancel out. So we have our efficiency finally to be what? 1 minus losses divided by what? Input power. Now, this is the equation you use to calculate for our efficiency here. But from our equation, we know our losses. We don't know our input power. But for us to get our input power, let's first calculate for what? Our output power. Now, output power is equal to what? Input power plus what? Losses. We already know our losses to be what? 7.032. What we are to calculate is our what? Our output power. From what we have here, we said our output power is equal to what? Input power minus losses. But on a normal sense, we've not calculated for our what? Our input power. So how do we go about it? Now take this down. Output power is equal to apparent power multiplied by packing factor. Now, from our given data, we have our what? Our packing factor to be what? 0.8, and we have our apparent power to be what? 500 what? kV. Now, using what we have here, we can calculate for our what? Output power. Now, if we calculate our output power will simply be what? 500 times 0.8. Now, the 500 is our what? Apparent power, and the 0.8 is our what? Packing factor that was given in our question. But what was given in our question was what? Power factor, not packing factor. And I told you that if you are not seeing packing factor, you will be seeing what? Power factor. Now, using that approach, we we'll simply have that what? Our output power will be what? 500 times 0.8. Now, if you do this, you simply arrive at what? 400 kilowatts. So we've succeeded in getting our output power. Now, from what we have here, we already know that our output power is equal to what? Our output power is equal to what? Input power minus losses. Now, we can get our input power from this equation. Now if we take our input power to this other side of the equation, we simply have what? Input power is equal to output power plus losses. This subtraction is crossing an equality sign, so it's becoming what? Addition sign. It's becoming addition. So you have what? Output power plus what? Losses. Now we already have our input power to be what? 400 kilowatts. And we already know our loss to be what? 7.032 kilowatts. So if we add these two together, we have our input power to be 407.032 kilowatts. And we've calculated for our input power and we've calculated for what? Our output power. Our output power is what? 400 kilowatts. Our input power is 407.032 kilowatts. What's the next thing? The next thing is to calculate for our efficiency. Now we know that efficiency is equal to 1 minus what? Losses divided by input. Efficiency is equal to what? 1 minus what? Losses divided by what? Input. We already know our losses to be what? 7.032. We already know our input power to be what? 407.032. What is stopping us from getting our efficiency? Now, efficiency from what we have here is equal to 1 minus, what's our losses? 7.032 kilowatts divided by 407.032 kilowatts. So this is removing this. So what you simply do is punch this in your calculator. 7.032 divided by 407.032. You have a value. Now what you press is 1 minus what you have here. You will get your what? Your efficiency. Now I told you, if you want to leave your efficiency in percentage, what you simply do is multiply by what? 100. But if you want to leave your efficiency, you don't want your efficiency to be in percentage, remove this 100. But what we are talking about is efficiency. So we want the efficiency to be what? In percentage. So what you do simply do is, after getting your answer, multiply your answer with what? 100. Efficiency to be what? To be 98.27%. Now don't forget, what we were calculating for is just for our what? Our full load. We've not calculated for our half load. We calculated our full load. We are calculating for our full load, and we calculated efficiency for our full load to be what? 98.27%. So in essence, your efficiency is simply what? 98%. So this efficiency is how this device which we are calculating for works. We've calculated for efficiency based on full load, and we got our efficiency for full load. For full load, our efficiency was what? 98%. Now they're asking us to calculate for efficiency based on what? Half load. Now take this down. For you to calculate for efficiency based on half load, for you to calculate for efficiency based on half load, you have to alter your what? Your copper loss and your output power. You have to alter your copper loss and your output power. For your copper loss, you alter your copper loss by multiplying 0.5 square to your value. You alter your copper loss by multiplying what? 0.5 square to your value. While for your output power, you take the half of your value. While for your output power, you take what? half of your value. So for half load, they gave us two conditions. Now the first one is multiply your copper loss by what? 0.5 square. And the second condition was take half of your output power. So your first condition was go to your copper loss where you calculated for full load, multiply what? 0.5 square to it, then come back to your output power, take the half of the value you got there. So now let's go into the calculation. So the first thing we do is for us to calculate for what? Our copper loss. Now our copper loss, for us to calculate, the formula is given by what? I1 square R1 plus what? I2 square R2. These are primary copper loss. These are what? Secondary copper loss. Now from our previous example, from our previous calculation, we got our primary copper loss to be 2413.2 plus our secondary copper loss to be 1718.8. Now what you do is add both of these. Now if you add them, you simply arrive at 4132. Now what did we do? We converted this to what? Kilowatts by dividing by what? 1000. Now if you do that, we simply have what? 4.132. Now this was what we arrived at for our copper loss. Now the condition they gave us, they said what? For your copper loss, multiply 0.5 all square. So what we've gotten here, you simply multiply this by what? 0.5 all square. You simply arrive at what? 1.033 kilowatts. So this is your new copper loss for what? Your half load. Now what you do next is take your copper loss, use your copper loss to calculate for your what? Total losses. Now to calculate for total loss, we know that total loss is equal to PC, which is what? Iron loss, plus what? Our copper loss, which is 1.033. Now we know our iron loss to be what? 2.9 kilowatts plus 1.033 kilowatts. So if you do this simple calculation, we arrive at 3.933 kilowatts. So this is our new total losses. This is our new copper loss. But what is not changing? Our iron loss, because it was a what? It was a constant given. Now after calculating for this, the next thing is to get your efficiency. Now we know that efficiency is equal to what? Output power divided by what? Input power. Now the first thing we have to do is to calculate for our output power. But we know that we cannot calculate for our output power if we don't know the formula to use to get what? Our output power. But recall that input power is equal to output power plus what? Losses. And we also know that our output power is equal to apparent power multiplied by what? Packing factor. We know our apparent power, we know our packing factor. Now we substitute our apparent power, which we know to be what? 500 multiplied by what is our packing factor? 0.8. If you do this, if you multiply this with this, you simply arrive at what? 400 kilowatts. But recall they gave us a condition, which was our second condition, and it says what, take half of your what, output power. So if you have 400 kilowatts to be our what, output power, what is half of 400? It simply means divide the 400 by 2. Now if you do this, you will simply arrive at what, your output power to be equal to what, 200 kilowatts. Now after that, we can use this to get our input power. We know our input power. We know that input power is equal to what, output power plus what, losses. We know our losses and we know our output power. So what is stopping us from getting input power? Now input power is equal to, what is our output power? 200 plus, what was our losses we calculated for? We altered our copper loss. So our new loss, which is total losses, will be equal to what? 3.933 all in what? Kilowatts. So if you punch this with your calculator, you simply arrive at what? 203.933 kilowatts. Now this is our new input power. What is the next thing? The next thing is to calculate for what? Our efficiency. We know that from this place, efficiency is equal to output power divided by what? Input power. We know our output power to be what? Output power to be what? Apparent power times packing factor. But recall, we proved that efficiency is equal to 1 minus losses divided by what? Input power. Now if we use this equation to calculate for our efficiency, we'll simply have our efficiency to be what? 1 minus, what's our losses? 3.933 kilowatts divided by input power is equal to what? 203.933 kilowatts. Now we want to calculate for efficiency, so our answer will be in what? Percentage. So this is what? Multiplied by what? 100. So if you do that, this will simply cancel this. So when you punch in your calculator, it's 3.933 divided by 203.933. You will get the answer. Then you punch 1 minus your answer multiplied by what? 100. You simply arrive at what? 98.07%. So in that case, what will be your efficiency? Your efficiency will simply be what? 98%. So this is your what? Efficiency for half load. Now we've also calculated for our efficiency for full load, and we said the efficiency for full load was equal to what? 98% too. So this is how you calculate for efficiency based on what? Your half load and your what? Your full load.